This lesson's on 10.2, product of powers property. So we're going to build on the last lesson on exponents and use that for part of the lessons for today. In example 1, we have product of powers property. When we multiply powers with the same base, we're going to add their exponents. So in the numbers case, we have 4 base to the second power times 4 to the third power. And so as long as the bases are the same, in this case both bases are 4, this 4 and this 4, so then we can write this as 4 and we're going to go ahead and add their exponents. So it becomes 2 plus 3, which we can simplify to 4 to the fifth power. And then if you were just writing in powers, we would leave it like this. If you have to simplify this or evaluate this, then you can work it out just like the exponents. We would write the 4 out, the base, 5 times. So we would write 4 times 4 times 4 times 4 times 4, and then we will calculate it out. In the case of algebra or variables, we do the same thing. We look at the base and see if the bases are the same. In our case, our base is A, so they're both the same. So we can use the same rule that we can add our exponents because we're multiplying. So in our exponents, it becomes m plus n. And because I cannot add those since they're letters, we're just going to leave it as that as our final answer. In example 2, we have a power of a power property, which means that we're going to multiply the exponents. Now at first it may seem a little confusing, so we're going to break it down to what we just talked about as far as the base and the exponents. Since our base is 4 to the 6th power, and the 3 on the exponent right here tells us how many times we're writing our base. So I'm going to go ahead and do that so you can see this. So this is basically 4 to the 6th, one time right here. And we have 4 to the 6th the second time, and 4 to the 6th the third time. So that's what it looks like because of that 3 on the outside. Tells me I'm writing my base 3 times. So in this case, because they're in multiplication, we can go ahead and add our exponents. So we have, since the bases are all the 4s, we have a 6 plus 6 plus 6. And that gives us 4 to the 18th power. Now that's one way to do this, is to write it all out. But a different way is if you look at the 4 to the 6th power and then the 3 on the exponent on the outside, think of this as the parentheses right here on the outside, and then you're distributing the 3 inside. So if you distribute that 3, and distribution requires multiplication, so that will be 3 times 6, giving us the 18. So that will give us 4 to the 18th power. So that gets us there quicker, but if you don't recall or remember how to do that, you can always go with what we just did on the first step. We multiply the base numbers, so because we're multiplying, we're going to add our exponents. Now in the same case for the algebra step, there is no number, so we're going to go ahead and distribute that, and that's going to be the base of A, and it's m times n. And that's all we can do with this problem, so we're leaving that. In example 3, we have a power of a product property. To find a power of a product, we're going to find the power of each factor and multiply. So very similar to our example 2, since I have a base inside the parentheses and then we have an exponent out, we're going to go ahead and distribute the exponent into the numbers are inside. In this case, I have 3 times 2 and then the 5 on the outside. Now, I don't have any exponents written in this case, so we can already assume that the exponent will always be a 1 if it's not written right there. From there, we're going to go ahead and we're going to take the 5 and we're going to distribute to each one of these guys right here. And that's going to give us 3 to the 5th power because it's 1 times 5. And then we have is 2 to the 5th power because again, it is 1 times 5 on the exponent. Now, if we don't recall it, you can always write this right here as 3 times 3 times 3 times 3 times 3, and then do the 2 times 2 times 2 times 2 times 2 times 2, 5 of those, and then put it into exponent form from there. Just put it into this form if that helps you out. Now in the algebra case, because we don't have any numbers, we're just going to go ahead and apply the multiplication rule. So we're going to take our m and we're going to distribute it into each of the base of a and b. So we distribute here and also in here. And again, I don't have an exponent on the top, so already the exponent could be assumed as a 1 right there. So then we can rewrite this problem as a base a with an exponent of m because it's 1 times m. And then we have as a b, same thing, exponent of m because it's 1 times m. Example 4, we're going to go ahead and simplify this. So now let's take all of our examples 1, 2, and 3 that we just learned and apply this. So again, there's two ways to do this. We can rewrite the base of 3xy and write it twice because that's what the exponent says. So we can write it as 3xy one time, 3xy the second time, and then we would have to simplify it. So when we simplify, we're going to go ahead and do 3 times 3. And then we have as x times x. So we can kind of gather them and combine like terms idea. So gather those guys and gather these guys right here. And then put it into our form. Now, if it's a number, always want to multiply the numbers out. So in our case right here, 3 times 3 gives us 9. And then if it is a variable, then we just put exponents. So it's going to be exponent of 2 because we have an exponent of 1 up here and it's a multiplication. So when we multiply, we want to add our exponents. So same thing with the y's. We have an exponent of 1 right there of each. So when we put it together, it's going to be y to the second power because we're adding 1 plus 1. Now, if you don't want to do it that way, the other way is to then go ahead and use kind of like that distributing property that we just mentioned about. So we have as 3xy to the second power, and we would distribute that 2 into each one of the bases right there. So we would multiply and multiply. So that would give us 3 to the second power times x to the second power times y to the second power. And the x's and y's look good because we just have it to the exponents, but the 3 we would have to simplify that out. And so 3 to the second power would then be the same as 3 times 3, which gives us 9. So our final answer becomes 9, x to the second times y to the second, which is exactly the same as the first one.